want you to start by doing number 1. Just draw out your two-way table for this scenario. So what I have on the board is the same thing that's in front of you, but instead of wasting time for you to write down all the problems, but you just still have it, I just printed it out, but you're not going to have room on there to do anything. So this one, I want a two-way table.
Two-way tables have two variables.
Mm. So two-way table has two variables. What's one of our variables? Shape. What's the other one? Color. Does it matter which one goes on the top, which one goes on the left? No. I think I did colors on the left, but it doesn't really matter. How many color options? 2. How many shape options? 3. Where does the 9 go? Bottom right's overall total. And this one kind of gives us conditional within. Like I said, I wouldn't usually do a two-way table with conditional, but these give you the counts, not the percentages, which makes it a whole lot easier to deal with a two-way table. So where does the 3 go? So this is probably 3 would be the answer, or 3 out of 9 is the answer for the probability of what? The ones that are red and triangle. So that's where they intersect. Where does the 4 go? Red total, which makes the blue total what? There are 2 circles, it's a total. One of which is blue, which means how many red circles are there? 1. Which means how many red triangles are there? Or red squares? There are 3 total squares. So how many of those are blue? 3. So how many blue triangles are there? 1. How many total triangles? 4. So just going through and filling in your pieces once you've written in the right thing. All right, so now we're going to use that two-way table to answer different questions. Some of them we're going through quick and easy. Some of it I'm working on showing your work. My one thing I'm slightly worried about with the quiz tomorrow as far as your test grades is I'm giving tomorrow as a Google form multiple choice quiz. but on your test, I'm grading your work. So I'm kind of slowing down a little bit to be like, on your test, this is what it should look like, but tomorrow I won't need to see that. So what would I probably want to write as my work for number 2? What is one word vocab for us that is talking about here? So how do I write the answer of a complement? Probability what? What is the probability of square? So my answer is 6 out of 9, which is 2/3. So making sure I'm being clear about how you need to share work on the test. Another way of doing this exact same problem, instead of saying 1 minus probability of square, you could write it as what? But showing your work.
You can add like one.
So you can do probability of triangle plus probability of circle and get to the same answer, and that's fine. Here, this is an or. So if it's or, I want to write them both out. So probability of red. What math in between? Plus probability of triangle. I need to ask myself what? Are they mutually exclusive? So because they are not mutually exclusive, I now have to do what? Subtract probability of being red what? And triangle. I've started writing your quiz, and I'm about up to 10 problems or so, and I have no math yet involved. It's things like, if I were given this, what would I look at? If I'm doing this process, what math would I be using? So there's a lot of like checking in between concept stuff. I'm going to do a whole section on that. So here, what is my probability of red? 4 out of 9. What's my probability of triangle? Minus probability of red and triangle, which is for a total of probability of square and triangle. So it's definitely 0, right? And what's the other thing you said? They're mutually exclusive. So if it's mutually exclusive, the and is always going to do what? Be 0. Because the and part is essentially asking how much do they overlap. The way most of you interpret mutually exclusive is, do they overlap or not? That's your answer to that question. So, with that same question, are red and blue mutually exclusive? You have 2 choices of what you can write as your answer here. I mean, yes is not the choice. Your justification. One way I could justify it is by saying what? They don't overlap, and which is the same thing as saying one figure can't be red and blue at the same time. That's my written thing of they do not overlap, saying the same thing. Or the other way I could say, this is why I know that they're mutually exclusive, is what?
They are beside each other.
That's the way you can think of it, but I don't want you to write that as your answer. What? That's again, you can think of it that way, but don't write it that way. What did we just say?
They're mutually exclusive.
What did we just say about these 2?
The and.
So the and was 0. That makes them mutually exclusive. that is enough as a justification. That's saying the same thing as the top one is. So I would accept the top answer is explanation or the bottom one is explanation, but they're saying the same thing. You don't need to say both of those. So now are red and circle mutually exclusive? No. So exact same thing. If I went with the top answer, or the top method of explaining, one figure what? Can be. A red and a circle at the same time. Which is the same thing as saying in words. Or I could write probability of, and because I know this answer, it just kind of helps me to say it. What is the probability of red and circle? But that's not where I would want to stop. I would want to say that this number, what? You're showing that that isn't 0. So either method of that would be acceptable. You're just saying in words what's going on, or through math what's going on. Do I go straight to independent with these same two things? With the same 5 and 6? Okay. Everybody still writing this? Alright, I want you to start writing 7. What you think, yes or no? So we learned how to show if two things are independent or not independent yesterday. Probability A and probability of B are independent if what? Probability of A is equal to probability of A given B. Probability that I do something is the same as probability that I do something under some condition. So I could pick either one here. So let's say I want to do it in terms of probability of red. What is the probability that one is red? 4 out of 9. And I'm fine with you writing these beside each other. What is the probability? So I'm comparing probability of red versus what? Well, if I'm only looking at the blue, what's the probability that it's going to be red? And what do I know about this number and this number? So because this one does not equal this one, I am writing what? They're not independent. I'm independent if I say the same. That would be a sufficient answer for this problem.
But why do we start the probability of red equals 4, 9?
You're showing that this number is not the same as this number. Like you're comparing this versus this. I'm just showing you what my numbers are because I have written it down. I can check these the other way and check probability of blue. What is probability of blue? 5 out of 9. I'm checking this one versus probability of blue given red. Because if I was checking probability blue, I'm still checking probability blue. What's probability that if I'm only looking at the reds that it's blue? Are these two equal? Does it matter if I go with this top half or this bottom half? No. If you are working on a problem and you've already done a whole bunch of math above it, look and see if you've already done one of these so you don't have to do more work. Other than that, it doesn't matter which one you choose.
So that's saying probability. What's the right half of it say?
Probability that it's blue, given that it was already red.
Is
0. If I'm only looking at the reds, it can't be blue. So here, I'm only going to do one of them for this one. So probability of red, what is probability of red? We've already done that one. I'm comparing that to probability of what? So now I have to actually at least look at this a little bit. So given that it's a circle means I'm only looking at these. So how many of them are a circle? 2. How many of them are red? 1/2. Are those equal? No, not infinite. And it's not like they're close, they're almost, they're either equal or they're not equal. Alright, 9 and 10. You should be fine with doing these. I'm making sure you see the difference. I've got these 9 figures in a box. They all feel the same, maybe written on a piece of paper. I select 2 shapes with replacement. So how many things am I doing? 2. I'm picking my first one. I'm picking my second one.
but you put it back, right?
So because I put it back, that makes these events what? So what's the first thing that I want to happen?
You want to draw
I want to draw what?
a shape,
And I want it to be what?
a red shape.
So what's the probability that's red?
What?
You have to think of things one at a time. My second event,
You also want to be a red shape,
I want it to be red.
but it would still be 4 out of 9.
I put it back, so what's the probability that's red? 4 out of 9.
And you add,
What if I had to add a word in between? I want a red one, blank a red one.
if
That or this way, this way. I want a red one and a red one. Should put it there. You don't need to write this off to the side, but it's basically thinking probability that your first is red and your second is red. You're doing this, but with these kind of problems, most people just write them like this. So, and mathematically means I do what? Or means what? Add, maybe subtract. And always means multiply. So it's 4 ninths times 4 ninths. 0.1979. Said
1975.
5. 6081 is not reduced, yeah. So 6081 or 0.1975, does it matter which way I write it? No. Alright, so now this problem
it's different.
is different, but it's basically one where if I asked you to think about this before you had ever been in my class, you would be okay with it.
Wouldn't it?
So think about it in pieces here. It looks like the same as this one to start. So what I want my first thing, I want my first one to be red. What is the probability the first one is red? 4 out of 9. Technically, this one is doing, so it is not independent, which means when I do this one, I have to write it as a what? As a conditional. So I'm technically writing probability that my second is red, what? Given that your first one is red. This is the process you're going through. To be honest, once you do 1 or 2 of these, you'll probably write probably red, and be fine with that. So there were 4 reds in there and 9 shapes in there. And I took how many out? I took 1 red out. So how many reds are left? How many shapes are left? Had I asked you to think through that before you ever started my class, you would have been fine with it. You're thinking about it the same way. And this one, let's do decimal. To do that one is decimal.
0.1667.
So with replacement, without replacement. With replacement always means that they are independent. So that's like, why do I not have to say with replacement when I'm rolling a die? You can't take it off the die, they're still there. So it's the idea of replacing it. And without replacement, I don't remember what question I just said.
It becomes conditional.
Yeah, the second part is conditional, yes. Alright, so now we're going to basically draw out what we just did. Even though you should be okay with that last one, like we can do problems this way. So we're going to draw a tree diagram where our first level is color, our second level is shape. So what options do I have, or how many options do I have for color? Which are red and blue. And I will tell you, today is one of those days where, more than anything, I'm going to have a section of the class that's like, I am so bored, this is so easy. And I'm going to have a section of the class that is like, please slow down, you are flying. And that's why I'm going a little bit slower today. Some people, like, probability makes sense to them, and some people it doesn't at all. What is the probability? So that's all we're looking at right now. What is the probability that I select a shape and it is red? So I'm writing that right here, 4 out of 9. So what is the probability that I select a shape and it is blue? 5 out of 9. Our second level is going to be shape. If it is red, how many options do I have for shape? Technically 3, and it doesn't matter if you write that last one because it's 0, but I'm going to go ahead and write them all so you don't get confused. Triangle, circle, square. How many options do I have if it was blue? Same 3, triangle, circle, square. So now let's think through this. When I'm getting to this level right here, I am under a condition. What is my condition that I am under? So at this point, this branch over here, I'm only looking at the reds. So if I'm dealing with reds, what's the probability that it's a triangle? What's the probability that it's a circle?
1.
What's the probability that it's a square?
0.
0 or 0 out of 4, doesn't matter. So then same thing with blue. If I know that it's blue, it's probably it's a triangle.
1.
Probably it's a circle. And square.
3.
These get real easy when you multiply down because the denominator of all of these is what? The denominator of all of these is what? the numerator here, which means when I multiply them, those cancel. So without reducing, this first path is what? 3 out of 9, 1 out of 9, 0, 1 out of 9, 1 out of 9, 3 out of 9. If you don't believe me, just multiply down. So now I can ask a question like, what's the probability that it was a triangle? Which would be this path or this path, which my answer is what? 4 out of 9. Is that what I would have gotten when I looked up here? So we already had that information. I wouldn't have had to go through the tree diagram to get that, but the tree diagram is showing the same thing. One thing that you will see, and I didn't write this as a problem, but I want to write something. So given, you might not need to write this. I just need you to be okay with it. Given that it's a circle, what's the probability of being red? Now, could I look at this graph and find that out? Yes. How would I do it here?
You go down the thing.
So I've multiplied down. How do I figure out, in general, what goes here? I need more room. We're saying probability of red given circle, right? So if I wrote this out, what would go here? So if I weren't given this and all I was given was this, how would I figure out what the probability of the circle is? That's this path and this path, right? Which is technically saying now what goes on top? What's the probability of the red and the circle? That's saying the same thing we did, it's just doing it a different way. It's connecting all of the pieces we did before together. Had I asked you to look at the chart here, you're going to get the same answer as if you do that. Had I asked you to do it individually and not think about it that way, you'd still get the same answer. It's like all these different methods that we use end up steering us in the exact same place. Now do I switch to different kinds of problems? Or do I have something more with that same?
Tree diagram.
Okay.
With the shapes and patterns for 2 dots.
Alright, so this is just a visual of number 10, essentially. Just so that you see what's going on and you see, again, how you could do it as a tree diagram. So this time I want to do 2 levels. The first level is shape. The second level is shape without replacement. So what are my options for my first shape? Oh wait, let's make it easier. Let's switch it and go colors so we don't have to write as much. And then I can tie in with number 10. What are my options for my first color? Red or blue? What's the probability that it's red? 4/9. What's the probability it's blue? I didn't put it back. Could my next one be red or blue? If the first one were blue, could the next one be red or blue? The first one was red. So how many red are left? How many total are left? The first one was red. Now how many blues are left? Out of how many? The first one was blue. How many red are left?
4,
Out of,
8,
and the first one was blue. How many blue are left?
4.
So number 10, I think I'm looking at the right number, is just that path. So that's just the visual that would go with the idea behind number 10. Do you need to draw all that out to figure out number 10? No, I would definitely not suggest drawing that all out to go number 10. But you see how it works if a problem were asked differently. What if the problem said, what's the probability that you select without replacement and one is red and one is blue? Let me just say, I'm not working for math here. Answer A, answer B, answer C, answer D. Those are our options to work with. What is the probability that I select one of each without replacement and I have one of each color? What? B plus C. Because which paths are one of each color? This one and this one. How do I get those? You multiply down. But I want this one or this one, which means I take this one plus this one. Questions about any of this or any of like you're thinking of things as I'm doing it?
You would get B and C, but in 4, like you'd get B, but in 4 nights times 5, right?
Yeah.
And then 4 nights and 4 and then half.
Yeah. Just 3. I want you to try those 3 really quick. Isn't it just 3 of them?
What's that?
Does yours have an F here and an F here? You doesn't matter what the letters are. It doesn't matter what the letters are. I could write like A and B instead of C and F. I was just trying to do different letters. I will give you a hint. This is the easiest problem you could possibly do. Not the easiest problem you could possibly do, but once I tell you, you're going to be like, duh. All right, let's make some associations here. If I'm dealing with this vocab, first of all, you looking thing or upside down. This word, if I'm dealing with this word, am I dealing with the U one or the upside down one? What word do I associate with mutually exclusive? Or. Which is which one? Which is union. What math do I associate with or? Do you see an issue? So can they both add up to equal more than 1? So what does that mean happened? There's overlap. What does it mean to be mutually exclusive? There's no overlap. So you're only, if I asked you to like write this out and show work, all you would do is So there has to be something to subtract. So we're starting out the same way here, but I give you a little bit more. So a lot of times if I see this, I'm going to start writing a direction of an equation. What direction of equation should I start writing? I know for a fact it's going to start with what?
P, probability of B
Plus.
plus probability of H.
But I don't know past there, right? But my option is what past there?
Minus probability of B and H.
Can I always write that? Because if that's not there, then that's just what? 0. So I'm going to say, okay, I don't know yet. Now I'm going to plug stuff in. What is this? What is this?
Plus 6.
What is this? So if I add these two things, then they give me that. Which means there is something here. Which means what? They are not mutually exclusive. So probability of V and H equals 0.3, which is not 0. So they are not mutually exclusive. And like these last three, I'm trying to do ones that I'm expecting you, like I don't have anything on here that's like, find the probability of this and this, or find the probability of just this, like that kind of stuff I feel like you should know at this point. So I'm trying for the ones that are trickier. Alright, so just like I did this one and I kind of started to write stuff and then see if I could think my way through it, I want y'all to do that with this one. So start writing stuff and see if you can think your way through it. So like P parentheses R alone probably wouldn't be like, oh, I know which direction I would go with that equation. So anything that's written that does have an equation as like a direction to go, I would kind of start writing that out and see if you can kind of start to fill in things. And this is usually your best bet of something to do on a test or the AP exam. If you start getting things like this, I immediately start writing things out, and sometimes I write more than I need to, but it kind of, you end up solving your way through it without realizing it. alone I can't find anything with, or I don't know what direction to go. Probability of y alone, I don't know what direction to go. Can I start writing an equation for my third thing? Okay, so let's start there. I don't know where to start, so I'm just gonna start writing stuff. What does that equal in an equation, not numbers?
R and divided by probability of y.
Do I have this first thing? Do I have this?
No.
Do I have this?
Yeah.
Okay, so maybe we want to go that way, maybe we don't. I don't really know yet.
But you can just find it.
Well, we don't know yet. So here, yes, but here, I'm going to go ahead and start with this one. What is my equation for that? And I don't know, but if there's something there, it would be, which same thing as R and Y. So do I have this? Do I have this? Do I have this? No, I don't have this either. So there's two things I need to solve for here. There's only one thing missing there, so I can solve for it, right? So this is what? This is what I want to find. What is this? So what math do I do there? Multiply both sides. So probability of R and Y equals what? So now I can plug it in there. So what is my probability Y? Probability R minus, which gives me that's probably one of my favorite problems that I've seen on AP exam is a problem like that. It's not the easiest one to do because you have to think through it. But if you start writing stuff out, it becomes easy a lot quicker than you would think. So you have to know what you're doing to answer it, but it's not like crazy. Yeah.
Is there like a different way to do that? Because I got the same answer, but I did.
What did you do?
I wrote out like the equation for probability of y or r, like 0.25 plus 0.3 minus probability of y and r. And then I added the 0.25, added those, then I subtracted probability of y times probability of r given y.
Which is what we actually ended up doing.
Yeah.
So you did the same thing. So like this is what I'm saying, like when we get to this, we're actually all doing the exact same thing, but it might not look like it. So the process he did is he multiplied your probability y to the probability y and r. That's actually what we did to get this. And then so we went this way, and he essentially went this way, but connected the same things, and it's all the exact same way. Questions with this? I'm gonna show you part of what